say that we set this in a discussion with Roz, we set this topic for today on a notion of tipping points. And this notion of tipping points comes into the climate discussion in two very important places. And so before we get going on climate, let me just kind of give you a sense of how I want to organize this. I want to first talk about this notion of complex systems very briefly. And that's where this notion of tipping points really comes in, the physics of it. We'll certainly connect it to the climate system. We're going to do that right away. But I also want to connect it to our society, to social systems as well. So let's just get started. Let's just think of the environment itself as a complex system. It comprises many, many subsystems, the Earth's cryosphere, the frozen bits, the biosphere, the living bits, land systems, ocean systems, the atmosphere, and all of the subsystems of those things. For example, in the atmosphere, we have the lower atmosphere, the troposphere, the middle atmosphere, the stratosphere. The ozone is an important part of all of that. And we could do the same thing with land systems and ocean systems. The whole point is that complex systems, one feature of them, of course, is that they comprise many other systems that are all completely entangled. And so that is certainly the case for the environment. Sometimes we break it up into atmosphere and ocean and land systems. And there are all these variables you've heard of. There are lots of variables that maybe you haven't heard of. But when you package it all together, let's think of this as one state, a climate state. When we think about how the atmosphere is and how the oceans are and how the land systems are and all the individual variables and the statistics of those variables and the normal ranges of those variables, let's think of all of that as the climate state. And that is itself a complex system. And one of the features of a complex system is this notion of twitchy behavior. So if you disrupt it, if you give it a little push, how does it behave? And it can often behave in very strange ways. You can, sort of poke this thing on one side and get a response on the other side in some place that you really didn't expect. And that is a feature of the physics of complex systems and how we describe them. So this notion of tipping points is one thing, and let me just then describe this. So if we think of that climate state as a marble in a little dimple, and we disrupt that climate state a little bit, one feature of complex systems is typically that if you disrupt them a little bit, if they're in a stable state and you disrupt them a little bit, the conditions around them tend to take them back to where you started. So we think of these as negative feedbacks. So I induce a change and the conditions around my system tend to dampen that change and reduce its impact. And we call that negative feedback. It doesn't mean good or bad. We can also call it a dampening feedback. So it just means that it takes us back to where we were. However, another feature of complex systems tends to be that if you disrupt them just a little too much, you cross thresholds, or what we call tipping points, beyond which the surrounding conditions no longer take you back to where you were, but accelerate you away in faster and faster to a very different, let's say, conditionally stable state from where you were. And we know, in fact, that the climate system behaves in this manner like most physical complex systems, in that it has these thresholds or tipping points involved. If you just go a little bit past them, it accelerates you away from where you were. In fact, this is the story of the glacial, interglacial cycles of the last several million years, where we're in an ice age for 100,000 years or so, and then we pop up into a warmer state like we're in now for 15,000 years or so, and then back down into the ice age. And that happens by crossing thresholds. And when you cross that threshold, the feedbacks in the system change from negative feedbacks or dampening feedbacks that take you back to where you were to positive feedbacks, or a better term is amplifying feedbacks that accelerate you away to a very different place. And again, we know that the climate system behaves in this way. And so it's something we're concerned about. And in fact, climate science and this whole collection of sciences that kind of combined is the study of Earth's climate system has identified a couple of dozen probable tipping points in our climate system having to do with changes in various pieces of a planet. So for example, how much polar ice is at the polar ice cap? And if we melt a little too much of that, that's a tipping point. That's a threshold that then begins to amplify the changes to the climate system rather than dampen the changes to the climate system. The amount of tropical forest we have on the planet, particularly in the Amazon, is a potential tipping point. If we get too little, then a little bit more change can have a really big impact on the climate. The amount of methane that is frozen in the tundra in the northern parts of the planet begins to melt. And if you start to melt a little too much of that, that can become a tipping point. If you dump too much fresh water into the North Atlantic by melting the ice sheet on Greenland, that can be a tipping point that causes dramatic changes to ocean circulation. So our climate system, we know, has these feedback loops that if you cross, lead you into tipping points that really then begin to accelerate you away from the place that you were. I'll give you one example of a negative or a dampening feedback, and that is the ocean system itself. So as we raise temperatures in the atmosphere, much of that energy gets absorbed by the oceans, and that's a good thing because you can warm up, you can add a lot of energy to water and change the temperature just a little bit. And so by absorbing that energy, the ocean system has a tendency to dampen the changes that we make to the atmosphere in terms of temperature. So both kinds exist in the climate system. It's the amplifying feedbacks that are really beginning to worry scientists now. So that's the notion, a very quick tutorial on the notion of an amplifying feedback in the climate system in a way that really is not working to our advantage. If we cross too many tipping points, it takes us into a climate system that is dramatically different than the one we inhabit, and one that is not at all conducive to an organized global civilization. I think most of you are familiar with the basic story of climate change, that we are warming the planet, how we're doing that principally through the burning of fossil fuels. And so I'm going to jump through all of that and assume that you're here to figure out what we do about that. And so what I want to do is add in this notion of a carbon budget, which I suppose many of you are familiar with. The idea is we can calculate, if we can identify what we think of as a danger line. And there are many danger lines, but if we could boil it all down to one, typically climate science tries to make it sort of easy for everyone to understand. We think of that as a global average temperature rise above pre-industrial temperatures. The science has identified 1.5 degrees Celsius, which is about 3 degrees Fahrenheit of warming globally, global average above pre-industrial temperatures, as a kind of a danger line. And given that danger line, one can then calculate how much more carbon do we think we can throw up in the atmosphere, carbon dioxide, and stay below that danger line. So just a couple of quick numbers. We have already warmed about 1.1 degrees Celsius, global average, above pre-industrial temperatures. Science has identified 1.5 degrees as a danger line, and that allows us to calculate a carbon budget. How much more carbon can we burn? And this is that budget as of almost 2 years ago, at the beginning of 2020, 340 billion tons of carbon dioxide, or gigatons. Now, that's not really an important number for you to remember. What we really want to do is think of scale, and what's important is how fast are we going to use up this budget. And this is a very easy calculation. We know how much carbon we're digging up and burning and throwing into the atmosphere. And so here's the answer. We expect before the end of this decade to have burned through that budget on our current trajectory. And so our task, all of us on this meeting today, our task is to make sure that we do not go past this budget. That is the goal. And there's uncertainty in this budget as well. And this was almost 2 years ago. We've burned through about 60 more gigatons. So really the budget is something on the order of 280 gigatons right now. So we burned through some of that. And let me just give you a sense of how much that is compared to the coal and oil and natural gas that we're digging up and burning. So here are those reserves. If you want a number, it's 7,100 gigatons. And that is about 19 times our budget. And so from a societal standpoint, hopefully this is quite clarifying. What this means is not only do we not need to find any more coal or oil or natural gas, methane, to dig up and burn, we can only burn roughly 5% of that which we've already discovered and we're already extracting. So no need to spend more of our resources on finding new carbon reserves. We've got 20 times more than we can ever burn safely. So that's the number that's important. So how do we not burn past that budget? Well, here's how much carbon we throw up into the atmosphere every year, going back to 1990. So over here in 1990, we threw up a little more than 20 billion tons, gigatons. Last year, it was close to 40 gigatons. And in order for us to not exceed that budget, not only can we no longer go up, as you can see, our emissions have been going up, we've got to peak and we've got to go down. And we have to do this very quickly. This is what we're going to call a rational decarbonization of our civilization. We've got to decouple our civilization from carbon emissions into the atmosphere. Now, what does that look like for the next 10 years? So now you're looking at out through 2030. On our current trajectory, we're just going to keep going up and up and up, as is shown here. If everybody on the planet follows the Paris agreements, the Paris climate agreements, this is what we're going to do. We're going to continue to go up and up and up, just slightly slower. And of course, this is what we need to do. We need to be on this low path to stay below 2 degrees Celsius, and in particular, we want to stay below 1.5, so even less than this. So we have a very big task in front of us, and that's if we start getting smaller right now. And this warming of the atmosphere, this global warming, will continue until those emissions reach zero. So we've got to get to zero as quickly as possible. Now, for the math nerds on the webinar today, if you add up the area underneath that curve, that gives you the total gigatons of carbon, our budget. And so you can see that if we don't peak now, but if we peak a little bit later, let's say next year or the year after, then the area under the curve gets bigger, and that means we burn up more of our budget up front. And if we're to stay on the budget, what that means is we have to make up that amount on the backside, which means that this decline has to be much steeper. For every year that we delay, the decline gets steeper and steeper. It makes it harder and harder for us to reach this goal. If we had started this decline in 1990, when we knew it was absolutely necessary, it would have been almost trivial to stay within our budget. But because we have now delayed and waited so long, it's no longer trivial, it's a monumental task. So that's the task before us. What does that look like, that decline over the next several decades? Well, roughly speaking, here's how much we have to do. We have to cut our emissions in half every single decade for the next several decades. And you can see that in this first decade, the area under the curve for those first 10 years is really big. That means this first decade, the one that we're in, is hugely important. That's where we learn how to do it, we get good at how we do it, and where we get rid of the lion's share of our emissions. And what that means is we need to decline our emissions globally by about 7% every single year. To put that in context, we've never ever done anything close to that. We go up every year anywhere from 0.5% to 3%. And so, so this is a very, very large decline every single year. Now, it's important to recognize that that's a global necessity. It's also important to recognize that not everyone on the planet has the ability to decline their emissions as much as others. This is not equally distributed. In fact, about 10% of the people on the planet are responsible for about 50% of the world's emissions. If the top 10% of the world's emitters cut their emissions to just that of the average European, that would knock a third off of our emissions right there. So you can see that the low-hanging fruit is not asking everyone on the planet to live a deprived lifestyle. Mostly the task is asking the very wealthy, the highest emitters in the world, to cut their emissions just down to the average of the European nation, who have very high living standards. And that gets rid of a huge amount. 20% of the people on the planet are responsible for about 80% of our emissions. That includes everybody on this webinar, I'm certain. And so again, those of us who live in the developed world have the lion's share of the responsibility to reduce our societal emissions. If you look at just the top 1% of the emitters in the United States, about 3.5 million people, they're responsible for as much emissions as 2,500 times the bottom 1% in the world. So in other words, people in the developing world, let's take sub-Saharan Africa or lots of places in Southeast Asia, are just trying to turn the lights on. And so asking them to cut their emissions year by year really isn't fair, particularly when you consider they don't really have a lot of room to cut. Their emissions are already very low, and they're not responsible for the problems we have. And so from a fairness, from an equity standpoint, and simply from a pragmatic ability standpoint, those of us in the developed world have the most ability to cut emissions in our personal lives and in our society. So what that really means is this 7% decline globally translates to about a 15% decline, more or less, for those of us in the developed world every single year. I want you to remember that number, 15%. And so here's the easy notion for what is required. This is required of us if we are to meet this goal of mitigating the extreme risks of climate change. We have to bend the emissions curve now. We have to stop going up. We have to start going down, and that has to start this year. We have to cut the emissions in half every decade. What that means is a 15% annual decline for those of us in the developed world for the next several decades. And this is applicable on any scale. And what I mean by that is from the national to the regional, to the state, to the local community, to the household, 15% every year. And so now what we want to do is talk about this. How do we actually do that, and what does that mean? It sounds like a Herculean task. And in fact, it's large. And in fact, it's not clear that we're going to be able to do this societally. From a technological standpoint, we have all of the knowledge that we need in order to do this. The question is, can we get ourselves societally to do it? And in society, oftentimes we frame things as viable. And what I want to do is reset our mindset and make sure that we've got in our minds the notion that this is now an emergency. And you'll hear lots of scientists calling it an emergency. The United Nations chief recently called the recently released Intergovernmental Panel on Climate Change report a red flag warning. What they mean by that, what we mean by an emergency, is very specific. It's a situation that requires an immediate response to prevent catastrophic outcomes. And when you're in an emergency, the guiding star is not what is viable. The guiding star is what is necessary to meet the conditions of the emergency. When we're in a burning house, we don't say, is it viable for me to take another step to get out? We just take another step to get out. We don't worry about it. We take another step, we take another step, we take another step. We do whatever is necessary to get ourselves out, or we die trying. So the answer to how is it that we follow this curve is manyfold. There are lots of things that have to happen. Oftentimes it gets broken up into, well, are there personal actions that we need to take, in our own lives to reduce our carbon emissions? Or is it societal? Is it our government that's responsible? Is it different companies that are responsible? And the answer now is that it's both. Because we have waited so long, and because it does take more time to spin up full systemic changes. Think about completely decarbonizing the electrical grid, completely changing our electrical system, completely changing our transportation system, completely transforming our food system. These are the three areas that are responsible for most of our emissions: how we power ourselves, how we move ourselves around, and how we feed ourselves. Changing those whole systems takes time, but we've waited so long. that we have got to make progress now. And so what that means on an individual on an individual level, as well as a societal level, is number one, we've got to consume less. Less consumption means less emissions. The energy that we use has to become 100% renewable. Our diets have to become heavily plant-based. Agriculture is responsible for roughly a third of our global carbon emissions. Industrial animal agriculture is responsible for approximately 80% of that. And so moving to a much more plant-based diet is simply clearly a necessity if we are to meet this emergency. And as we're waiting for our food system to catch up to us, we personally can do that. We need to add incentives in our economy to get away from carbon. That means pricing carbon. Various forms of carbon pricing, carbon taxes have been proposed. Those need to be enacted as quickly as we can do that. And we've now gone so far that it goes beyond carbon pricing. We're going to need to ration the carbon. Let me give you an example of why this is necessary. Here in Utah, most of us have a carbon footprint of about 18 tons of carbon every year. However, if we are to meet that budget that I showed you earlier, 340 billion tons, and if we were to divide that 340 billion tons equally among everybody on the planet, that would mean that everyone would have a lifetime carbon ration of about 44 tons. So here in Utah, that means that on our current path with our current behaviors, embedded in our current society, we Utahns will burn up our personal carbon ration in about 2.5 years. So we all know that without serious inducements, for example, some kind of rationing, that's just not going to get us to where we need to go. But let me give you one more number that's pretty interesting. So if each of us were to simply turn off all the lights, never step in another car or step on another airplane or eat another piece of meat or dairy, and just sort of sit in the dark in our homes and decompose on some garden seeds, reduce our carbon budgets as much as possible, all of us on this call would still have a carbon footprint of about 6 tons per year. And that's because we're embedded in our Utah society. The carbon that it takes to maintain the infrastructure that we exist within, the roads, the buildings, the transportation systems, all of those things that just, even if we don't use them, they exist and get used by others anyway. So in other words, if we were to just live completely deprived lives, we would use up our carbon budgets. Instead of 2.5 years, it would take us maybe something like 6 years or 7 years. So it just doesn't buy us enough. And so we have to transform the system that we're embedded in as well. And so as we move forward, that should say carbon ratio, carbon ration. As we move forward, we're going to need to, in addition to our personal transformations, which are absolutely necessary because they can happen right now, we need to transform the systems. Whether or not we consider these politically viable is not really the question. We have to make them viable. We have to do that through our own engagement with public policy, because this is necessary. And most of all, we have got to keep the existing carbon reserves, coal and oil and methane, in the ground. We can't extract more. This is whether we regard it as viable, the physics doesn't care. This is what is necessary. And I think it's clarifying for us to know this. Our new goals are a sustainable and a just and a vibrant existence for all people. And I think these are goals that we all can agree upon. And so now the question is, how do we go about doing that? As we move forward then, from what I talked about, I'll come back to this. We've got some lessons about the notion of viable versus necessary from our recent experience with the pandemic. And I think this is an exercise that's happening in all kinds of organizations and all kinds of contexts. But let's just review my takeaways, what I think are some broad takeaways from COVID. And the first is, that we as a nation can do much, much more than we think we can. When we recognize an emergency as an emergency, we can pivot on a dime. Think of what happened a year and a half ago in March, when we recognized we were in an emergency and how quickly we were able to transform the way our society operated. This so-called COVID shutdown, where only essential services were going. We transitioned to working from home. Some of us already knew how to do that. Some of us had to figure it out, both personally and systemically. Think of the Zoom system we're using right now. We got a lot better at that very quickly. And in fact, many of those changes are going to remain as we go forward. I think if the data shows that lots of businesses are thinking about rethinking how they do business. Do we need people to come to work in an office park? Or can many more people work from home? It has a lower footprint, it has lower costs. There's lots of win-win that we got from meeting this emergency. And we found out that we could meet the emergency and pivot on a dime immediately. We also found out in COVID that as a society, in terms of our resources, whether they're financial or material, we can afford anything that we can actually do. We can afford anything that we can actually do. It's the advantage of having a national response, a nation that actually is in control of its own money supply. We can afford whatever we can do. And we found out that spending those resources, that money, for example, the payroll protection plan, the so-called PPP, was an investment in the health. It wasn't a cost to us as a society. It was an investment in our future well-being. It was keeping people paid and healthy and happy and surviving while we did all of the things that were necessary to meet the emergency. If we can do it, we found out in COVID that we can afford it. Because we think of it not as a cost, and not just think of it, because it actually is not a cost, but is an investment. What we also discovered, though, is without meaningful, strong public policy, all of the steps that we take don't last. Without genuine public policy, we will not be able to get ourselves to do what needs to be done. And COVID is a perfect example of that, of course. Without mask policies, we couldn't get ourselves to get ourselves masked up. Without a vaccine policy, we cannot get ourselves as a nation. I think we've seen this. And I'm not making a moral judgment here. I'm simply saying pragmatically, we have data. When it's hard, or when we perceive it as hard, or there are barriers, in the absence of strong public policy, we can't get ourselves over the finish line, which is why we have a new variant. If we had been able to vaccinate quickly enough, you can shut down the number of people hosting this virus and shut down the ways that the virus has to mutate. Without that, we got a new variant. And in fact, we have yet a new variant now called the R1 that has arisen in Kentucky and is infecting both vaccinated and unvaccinated people. So, and that is, of course, been in the absence of genuine, strong vaccination policy. So even though we can identify our science, our knowledge base can tell us what we have to do, even though our technology can provide us the materials we need to do it, whether it's masks or personal protection equipment or vaccines, in the absence of public policy, we cannot get ourselves culturally to do what needs to be done. And so we need genuine public policy. And this is not new. We have done this in the past to meet emergencies. World War II is always a classic example. What did we need? We needed to ration things like rubber and metal and flour and meat. We needed money to finance it through bonds. We needed a national industrial policy that told the car makers that they were no longer allowed to make automobiles. They had to make tanks and airplanes and trucks and munitions. We had strong national policy to meet the emergency. And without that policy, that emergency would not have been met. So we need genuine public policy to do what needs to be done. But we've also discovered in COVID that without genuine leadership, there will be no public policy. We've seen a continuous process of those in leadership positions, whether they be mayors, whether they be governors, whether they be our national congressional leadership, even as far as the presidency, passing the buck and leaving it up, mayors leaving it up to teachers in the classroom, leaving it up to school boards, governors leaving it up to individual communities, et cetera, completely passing the buck. And so we've discovered that in order to meet these large scale challenges, we need genuine leadership before we can have the real public policy. And we have also discovered, I think, in the last couple of years, that without citizen engagement, there will be no leadership, but with citizen engagement, there will be leadership. And I would argue that in the case of COVID, at the national level, the leadership on this has recently changed. And I'm not saying this as a partisan, but clearly as we changed administrations, the approach to public policy has changed dramatically for the better from the standpoint of actually meeting the emergency of COVID. And so these are what we have learned. So asking the question, is this possible? Is this not possible? Isn't helpful because it's not answerable. We assume that it is possible, but in order to make it possible, we've got to have genuine engagement from us to get the leadership, to get the public policy, because we have to change these systems. Okay, so this is kind of where I'm at. I want to leave you with the following notion, and we're going to round ourselves back to tipping points to close this out. If you don't remember anything from this presentation, I want you to remember 15%. 15% this year is required of all of us to reduce the amount of carbon we put in the atmosphere. Our society needs to reduce emissions 15% per year, but it will not happen through systemic change this year. The changes are so big. And even though parts of them, those changes are underway, it takes a while to spin up. We're not going to get to 15% down. In fact, if we continue on our current trajectory, we're going to be 3 or 4 or even 5% up in our emissions this year. And as you saw, we can't let that happen. We've got to go down. And so in the upfront part of these next several decades, and in particular this decade, the lion's share of the emissions is going to fall to us individually to reduce our emissions 15%. And the good news is this is pretty easy for most of us to do this year. The biggest sources of our personal emissions are how we move ourselves around, how we eat, and how we heat and cool and power ourselves. So ask yourself, could you eat 15% fewer animal products this year? I think most of us can do that without even thinking about it, and even gain health in the process, and do it not with iceberg and cottage cheese, but with wonderful, tasty, delicious food. That's all available. Can you eat 15% less animal products this year? I think we can all do that without any negative impact to our lives. Can we travel 15% fewer miles, whether they are air miles or vehicle miles? I think most of us can figure out a way to do that. Can we use 15% less energy in our homes? I think most of us can figure out a way to do that this year. But then we need to do it again next year. And it gets just a little bit harder if the systems around us are not changing in order to help us. And then we need to do it again the next year. And it gets harder still if the systems around us continue to fight us instead of to help us. In other words, you can try to purchase an electric vehicle, but if you're plugging your electric vehicle into the wall, approximately 80% of that energy is coming from burning fossil fuels. So if that doesn't change, then your investment in an electric vehicle doesn't help that much. However, if you invest in an electric vehicle now, and we begin to decarbonize our power grid so that it's not 80%, but 5 years from now, it's 30%, and then 5 years from then, it's 10%, of our electricity is coming from fossil fuels, then the system changes are really helping us. And the same with our food system, and the same with our buildings, and the same with our transportation systems, et cetera. So 15% this year, it's what we have to do on a personal level. And most of the time it won't be that hard, but when it is, when you would just much rather drive than walk or ride your bike, when you would just really want to have that steak or that burger, but you can't because of your budget, when you would really rather crank the air or crank the heat, but you can't because of your budget, well, you can thank ExxonMobil. You can thank Chevron. You can thank all of the fossil fuel companies who for 30 years have been working their hardest to get us to delay these changes in the name of profit for shareholders. But regardless of who's to blame, 15% for us personally this year at a minimum. We're at the emergency crisis stage. Now, of course, we don't want this to go on forever. And as I said, it gets much easier if the systems are changing. And so what that means is that in addition to making these changes in our personal lives, we have got to be engaged heavily as citizens with forcing the issue in our public policy to force the transformational systemic changes. And fortunately, there are many ways to do that. I'll give you simply one example of something that's very clear to those of us who work in this field that absolutely has to happen. There are two pieces of legislation before our National Congress right now. One of them is the National Infrastructure Bill. The other one is something called a budget reconciliation. But embedded in these two pieces of legislation are enormous investments of a proper scale in the kinds of things that we have to do to transform our systems. And these aren't simply things like deploying lots of solar power and lots of wind power and lots of energy efficiency. It's that, but it's also heavy investments in the well-being of all of us who have to be engaged in doing this work. People who are sick, people who are uneducated, people who have no access to childcare or to elderly care for their parents, people who are worried every single day about their health, about their nutrition, are not going to be people who can engage effectively in meeting these challenges. And so we have to engage and invest in the well-being of all of us as a society. And so those investments are in these pieces of legislation as well. And the idea is, even if you don't care about the well-being of other people, and I'm pretty sure most of us do, but even if you don't, those people, all of us, are necessary to meet these challenges. Someone once said, in order to change everything, you need everyone. And everyone's got to be healthy and secure with access to living wages and childcare and elderly care and healthcare and education. We need that. And embedded in these two pieces of legislation are investments in those things. Those things have got to get passed. And as it turns out, it's happening this week. So we have got to be heavily engaged in speaking with our policymakers that this is non-negotiable. These things must pass. With, again, the notion that you'll run into from your policymakers, we can't afford it. And the answer to that is, yes, we can. These are not costs, these are investments, and we can always afford investments. So let's bring it around to tipping points. I think many of you who've been working on these issues feel like you're Sisyphus, pushing this rock up the hill endlessly. And we've got our head down and we're focused on doing the thing that we need to do, and it feels impossible. So just though, as in the climate system, there are all of these hidden pieces that work against us, these tipping points that move us from small changes to bigger changes to bigger changes that we don't want to see. The same is true in social systems, but in the other way. Because in our environment, there are lots of things we don't see, lots of other people doing work, lots of pieces to this complex system that we're not always aware of. And if we keep our head down and we keep pushing our rock, at some point we cross thresholds where the systems are no longer fighting us, but they're helping us. And it comes from these huge collective actions that are already underway everywhere around the world and everywhere in our nation, and certainly everywhere in our state. There are so many things to plug ourselves into. Well, so we keep our heads down, we keep doing the work every single day. We work up, we push our boulder up the hill, and pretty soon, at some point, and we probably won't even know when we cross that threshold, the social forces around us start to work with us instead of against us. and we get to where we need to be. This is the story of every successful social movement in our history, from from civil rights of all kinds, from women's suffrage to racial equity, to marriage equity, to workers' rights, you name it. It's been huge organization, lots of people doing their bits until we get things over that tipping point, and this is, social systems begin to work for us rather than against us. And this has been the story of social change for our entire history. So just as there are tipping points that spiral us down a hole into places we don't want to go, there are also tipping points that spiral us upward and make it easier and easier to reach the results that we want. And there's evidence of it all around us. So I'm going to end with that note. I'm going to take you back to this 15% and simply say that as we move forward, you will be told that you are radicals. You are not. You are being rational. You are rationals. Nevertheless, we have to be radical with our rationalism. We have to be extreme with it. In other words, we need to be radical rationals. But the things that we're engaged in trying to change have to change. That is a rational response to an emergency. We simply have to be radical in our approach to doing it, meaning we have to be resolved, we have to be unrelenting. So thanks everybody for your attention. Thanks again to you, Roz, and to the Utah Climate Action Network, and everybody who's putting together all of these events for Climate Week. I know that we've got Catherine Hayhoe speaking later in the week, and that's going to be an amazing talk. She's a wonderful scientist and communicator. And so with that, I'm happy to open it up for discussion